Hello and welcome to the Active Atom Educational Series. Part 2, Disassembling a Precision Machine Spindle. Okay, if you're here at Part 2, we're hoping that you've watched Part 1 already of the series. If you haven't watched Part 1, you need to go back and watch it. It will much better lay out what you're about to see us do, the types of tools and all types of equipment you're going to need, a little bit of a great line of preparation taking place and stuff like that, right?
I agree. It's going to prepare you for this part.
Now, if you're looking for the disassembly of all these different spindles you see in front of us here, we did these in advance months ago. And the reason we did these in advance was because we didn't know what's inside and we had to procure things, buy things, put things together, machine some parts, rework some parts, and do a lot of prep and details. On that note, we did that so we could keep the series on schedule to give you something you can use today, not like delayed by 2 months or so.
That's right. We didn't want to release like one part on the disassembly and then wait, 2-3 months later and release part 3 for the assembly.
Yeah, when you really need part 4 and you're never going to get it at that rate.
Exactly.
So, but knowing that, we do have several extra of one of the spindles, huh?
That's right. This is a Levin accessory spindle, and we actually have a few of these. So what we've decided to do is we decided to go ahead and disassemble this spindle. And although it's not a headstock, a lot of the procedures we use, for removing the spindle, removing the bearings, is pretty much the same method we use.
Quality of workmanship.
Exactly.
All the details.
Yeah, so everything we do on this spindle is pretty much applicable for the headstock spindle.
It's just the smallest one.
Yeah, it's just the smallest one. And the main difference is, this has just a pair of angular contact bearings, where the headstocks has an additional deep groove bearing. So 3 bearings total instead of 2 bearings. But other than that, the procedures on removing the parts and disassembling it is pretty much the same.
But they'll get to see all of that in the assemblies, right?
That's correct. That's important. In part 3, we're going to show you the assembly of actually 4 spindles. We're going to show you the assembly of a Levin accessory spindle, an open style headstock, and 2 closed style headstocks.
And to us, that part was really, really important. It's the assembly is really important. There is variations on that assembly.
That's right.
Reassembly. So there you go.
Okay, let's get going.
All right. Part 2, Section 1, Removing the Belt Pulley.
Okay, we're ready to start disassembling the accessory spindle. And this first step is actually pretty straightforward. But why don't we get a close-up view for this first step?
Oh, great.
Alright, that's a better view. Okay, for this spindle, this is pretty simple. All we need to do is loosen a set screw. Okay, there he is. Okay, so right there, it's a little tiny set screw, and all we need to do is, we don't need to remove it completely, just loosen it for now. Okay, and then it should... Okay, so that came out pretty easily. Hey, these usually come out pretty easily. If not, then you got some problems, but there you go. Okay, and that's all we're going to do in this section. But while we're at it, I want to share with you the procedures for the headstocks. Okay, this is the open style headstock that many of you will be familiar with. And in this configuration, we've got the belt pulley right in the center like this. In this case, the first step is you'll see the set screw right there. See, in one of the belt grooves, or V grooves. All we want to do is we just want to loosen the set screw, and then that's it. And then we don't want to do anything else because obviously we can't remove it until we remove the spindle. But you see, you want to make sure you loosen or even remove. I'd actually, in this case, I would remove the set screw completely.
Be sure that's free.
Yeah, be sure it's free. Exactly, because if you forget to loosen that set screw, you're going to pound that spindle out and you're going to damage the spindle, and that's not going to be very good.
No, that's a bad thing.
Yeah, so very important. And then also let's bring in a closed style headstock. Okay, in this case, okay, we're looking, yeah, this is the rear of the spindle right here. And for this headstock, we got the belt pulley for it. See right here? See, in this case, so you got the spindle coming out, and see, and this installs right on the spindle, and it sits right there. And there's actually no set screw. I just want to show you how this is secured or fastened on the spindle. It's actually held in by the spindle nut. So basically, you got your spindle sticking out. It also has a keyway. See, and the spindle nut goes on, and that's how it secures the belt pulley. See? And then obviously the key right here keeps it from spinning. So that's why you don't need to do anything. So if you try looking for a set screw, you aren't going to find any. It's being secured by the spindle nut.
Great.
Okay, so that completes step 1 of the disassembly procedure. And we're actually, for the following steps, we're actually going to move out of this workshop and we're going to go over to the machine shop, because for the following steps, we're going to need the big bench vise and we're going to need the hydraulic press.
That's right.
So
that's right. We get to share that with you.
Yeah, so it'll be pretty exciting.
Yep.
So we'll see you there.
Part 2, Section 2, removing the bearing caps. And we're here with Patrick in a blue coat in the machine shop.
Yes, we're here for this section because we're going to be using the bench vise over here. Okay, let me show you first the accessory spindle that we're going to be disassembling for you. The bearing caps are these 2 caps at each end of the spindle. And for the accessory spindle, we're going to be needing the spanner wrench for both. And we also brought out the headstocks because if you're disassembling a headstock, we kind of want to share, if you're at this stage with your headstock, this is what you'll want to be doing as well. So if you're doing an open style headstock, you have these 2 bearing caps. Oh, and by the way, some people also call these dust shields because, for the open style headstock and the accessory spindle, they also contain the felt rings. So that's why people refer to them as dust shields. So, but we'll call them bearing caps for this lesson.
Oh, got it.
Okay, so these you'll also need for the open style headstock, you'll need the spanner wrench for both. Okay, and then once you remove the spindle, there's also the internal bearing caps. And see, these are actually, they go on the inside, and then you have the belt pulley in the center. And you'll notice they're just press fit. Okay, and they're press fit about halfway. And why you need to remove these is because you'll see the felt ring and then you see the retaining washer. And so what you're going to need to do is you're going to need to pop out the retaining washer, and then you're going to have to clean the felt ring. And we're going to show you how to do that as well. Okay, so that's that. For the closed style headstock, for all the closed style headstocks, you don't need a spanner wrench. For the front, we actually have 2 pieces. We have the bearing cap, and then we have the slinger cap. And if you notice, for both, they use these little socket head cap screws. And what we recommend, as we mentioned before, be sure you use a quality set of Allen wrenches or hex wrenches. Because, as you know, especially this one, they're very small. If you use a cheap set of Allen wrenches, it's going to strip. We find a lot of stripped socket head cap screws. The next thing you want to do is, you'll notice for the rear, this is the belt pulley. And normally it sits right in here. And see how there's a little recess right here and there's a slot right here. So it forms a pretty good closed seal. Not tight seal, but enough so no dust is going to get in. But then as well, there's also a pulley guard that goes over. So that's like double protection. And to remove this is removed and secured by the spindle nut. So when it comes time to remove the spindle nut, that's when this comes off. And then you'll notice there's also a key So when you remove this, be sure you don't lose that little key because it's really small. And we've lost one before, so we know by personal experience. So just wanted to share that on the headstocks. So let's go ahead and get started on this. And okay, we're gonna be using this bench vise, and we want to be, you know, like we keep preaching, we want to protect all the parts. You know, we want to be very careful. We don't want to scratch, ding, or mess up any of the parts. We're gonna use soft jaws, and the ones I selected, I believe, is leather. Yeah, this is leather. Okay, that should be good. Okay, one of the things you'll notice is, okay, people that aren't familiar, this is the Levin grinding attachment. This actually gets mounted on the cross slide, and you'll notice I've kept the spindle attached. Say it's attached with these 2 socket head cap screws, and I kept it attached to the bracket because that's going to give, you know, that allows me to hold it very well. Because see, if I had already removed the spindle, you know, it's circular, it's going to be very difficult to hold and too easy to drop it and damage it. So that's why I kept it here. So especially if you're doing like a Levin milling attachment or a grinding attachment, you know, leave the spindle housing attached, you know, to either the bracket or the milling attachment to remove these caps. Then once you do that, then you can remove the spindle. Does that make sense?
Yeah, I can see that.
Okay, what we're going to do is, okay, I'm going to first remove the rear bearing cap. So this is the rear spindle, at the rear side of the spindle. So we'll see right there. Okay, and what we're going to do is, I'm going to share the use of 2 tools. I'm going to remove the rear bearing cap with the homemade tool that our mentor gave us. And then for the front bearing cap, we're going to use your common spanner wrench. And we want to use both because we want to kind of give you an example of, you know, how you use a homemade tool, as well as probably most users that are going to be doing this procedure are probably going to use a spanner wrench. So we'll first use our homemade tool. Okay, and you'll notice there's 2 holes right here. And this is a really nice tool that we shared earlier in part 1. See, this actually has the little pins for the rear cap, and it has the larger pins for the front cap. So let me see. Okay, that's in. Okay, just a little insight. These are usually not on very tight. Especially when you're using the right tools, this is really important. When using the correct tools like we're using, they come out fairly easy. It's when, you know, you aren't using the proper tools, they seem like they're welded on. And I think that's where people damage the parts. You know, they get their serrated, you know, pliers like Lance showed earlier, and they really damage the caps. So just wanted to mention that. Okay. Oh, that one came up too easy. So see, with the proper tools, not bad at all. Okay, there you go. Okay. So you can see we got some old grease. Let's see if I can. See, that's actually really old grease that's hardened.
Oh, like a brown in texture there, huh?
Yeah, see, it's brown and it's really hard, see? Okay, so we got that one off, and let me see if I can show you how it looks inside. Okay, I can show you, this spindle has never been rebuilt because I can see it has the original new departure bearings. So, yeah. Okay, and see, you can see this is a spindle nut right here.
Oh, okay.
Okay. Okay, now we're going to use the spanner wrench. And what you got to be really careful, okay, you can see the slots right here, they're half moons or half holes. You know, they aren't full holes. And the reason why I mention that is because if you aren't careful, what happens is it'll slip very easily. So see, these pins will easily come out of the holes, and then you'll damage, the outside of the bearing cap really bad, because these bearing caps are made in soft aluminum, so you gotta be really careful. So what I do is, make sure they're in the slots very secure. See, just like that. And then what I do is I get, my left hand, and I'm applying pressure because I don't want this to slip, like I mentioned. So with this hand, I'm, putting down, force between the two holes, and then okay, see there, just like that.
I just wanted to point out that you notice nothing aggressive is being done here. There's no pounding and tapping even at this point. There's just...
That's great. You make a good point. If something feels that it's requiring too much pressure, too much effort, you need to stop and analyze the situation, because it really shouldn't take that much effort. And Lance makes a good point, because a lot of people tend to put all their might into it, and then again, that's where you damage parts. This one is, you'll have to use a spanner wrench to remove this entirely, because you've got this other shield in front, and that's actually press fit onto the spindle. So when we're loosening the bearing cap, we're actually pushing the other cap off of the spindle head. Okay. Okay, see, I'm just taking my time. Okay, I feel it. There we go. Okay, let's see if I can. Okay, see, now we got the two parts. So see, this one's the one that's press fit on the spindle head, and then this is the bearing cap that has the felt ring with the retainer washer. And see, just like the other one.
Hey, look at all that grease or oil there. Look at that.
Yeah, and see, you can tell it's a very dry grease. Okay, and let's take a look how it looks inside. Okay, let's give you a view of how it looks. Not bad, but I can tell you, this is in such bad condition. It's very difficult to turn.
Remember earlier we showed the wire going,
that's right,
pulsating. Pop, pop, pop,
exactly.
Pop. The green wire, yeah.
That's right. So this one's a really bad condition. Okay, well, I think that covers everything. So we're done for this section.
Part 2, Section 3, Removing the Spindle Nut.
Okay, before we head over to the hydraulic press, there is one important step. We need to remove the spindle nut. So we're going to do that in this section first, and then we'll head over to the press. Okay. Before we start the procedure, I just want to share the kind of some notes and hints and suggestions on all the three spindle types. Okay. So if we first look at the Levin accessory spindle, okay, we still have the bracket on. We don't want to remove it yet. We're still going to use the vise again. And what's kind of interesting, although this is the smallest Levin spindle, this is actually the most difficult nut to remove. And the reason being is, unlike the other spindles, this has no locking mechanism to lock this spindle. So when you're removing this nut, how do you hold on to the spindle? And we're going to share that. And if it's too tight, we're going to share the method we use, so that way you don't damage anything. Okay, but before we get to that, let's talk about the open style headstock. Okay, at this stage, you want to be sure that the belt pulley is still very secure with the little set screw. So be sure, I'd probably double check, make sure the set screw is very secure and tight onto the spindle, because what we're going to do is, for removing the spindle nut in the back, you're going to be holding on to that belt pulley. And again, you know, it's still, that pulley is being held by that little tiny set screw. So you got to be very careful. If that nut is really on there very tight, then we are going to recommend to use the method we use for the little spindle. Okay, on the closed style headstock, in the front right here, you know, there's that little knob that you push in, and that's what locks the spindle. And on this particular style of headstock, this is actually very durable. It's very rugged, and this is the method Levin uses. So they use this locking mechanism to lock the spindle, and then you can, you know, remove the nut. So unlike these, where it's, you know, they're very sensitive, this you can depend on the locking mechanism. That's the other thing I want to point out real quick. Okay, a lot of these watchmaker lathe headstocks, you know, you have that little pin to lock the spindle. We don't recommend using that because it's just too fragile, and that pin's just too tiny. So that's why we recommend holding on to it with your hand. Okay, some of the tools that you may need. Okay, let's first go over the tools you will definitely need for this job.
Can I hold up right here? These additional tools he's about to mention to you, which were not shared in the workshop area, but are being shared in the machine shop area, will be in the drop-down live document for under the tools required for to do this project.
Sure, good. Yeah, so you don't have to write all this down.
No, very just important. Come along now and pull the document.
Okay, first thing you'll need is, let's see if I remember. Oh yeah, for the accessory headstock and for the open style headstock, you'll notice the spindle nut, there's a little locking fastener that locks the spindle nut. Okay, and on these two spindles, you're gonna need a little flathead screwdriver, you know, just like this. Okay, and again, we're gonna give the details. And again, you know, we use a good quality tools. This is from Xlite. Okay, and then on the closed style headstock, it actually uses a little socket head screw. So you're gonna need Allen wrenches. Okay, so you're gonna need the flathead screwdriver for the accessory spindle, open style headstock, the hex wrenches for the closed style headstock. The other tool we recommend is some soft jawed pliers. So as you can see, this has some nylon jaws, and this is going to allow us to hold on to one end of the spindle, you know, pretty tightly without damaging it. So that way we can then use our little spanner wrench and then remove the nut. But you got to be careful, this can only hold on so well because you also don't want to press too hard as well. So if you can't remove the spindle nut with these pliers, then the other method is going to require a small little hammer. Okay, you don't want to go larger than this. Remember, very delicate equipment, so you only need this little small hammer. What is this? This is a 2-ounce hammer. Okay, and then you need a good quality punch. And the punch we recommend is a 1/8. Yeah, that's what we like to use, okay? And we're going to demonstrate it, how to use them. Okay, and I think that's it. Oh, and then the spanner wrench we use, you're going to need the spanner wrench for removing the spindle nut, because you can see you got the slots right there. And then we put the spanner just like that. Okay. So are we ready to demonstrate it?
Okay, let's see if how we do here.
Okay, great. Okay, I think we're gonna go like this. Okay, so yeah, you want to put in the vise, just like so. Okay, so we're gonna take our soft jawed pliers, And at one end, okay, yeah, it's pretty good. So let me line this up better. That's better. Oh, before I forget, so I almost made a mistake. Very important, because you'll damage it. You gotta loosen the screw, because this is what locks the spindle nut onto the spindle threads. We don't have to remove it, just loosen it. So a few turns. Okay, now we're ready. Okay, make sure we're in there really good, okay. There, I think I felt it. Oh, great. Okay, we lucked out, because I tell you, most of the time, it doesn't come off that easy. So I'm going to show you here. I'm just going to hand tighten it. I'm going to show you the method to use when it's when the spindle nut's really on there tight.
Which is 99% of the time.
That's right. Okay, at this stage, we know the first method didn't work. Okay, so what do we do? I'll tell you, a very common mistake a lot of users make is they think, okay, well, you know what? I'll just insert like a 3-jaw chuck. That way I can insert it in and then hold on to it with my hand. But the problem is that little collet key inside the spindle, it's really small and fragile. What ends up happening is they end up shearing it right off. So you don't want to do that. You don't want to put anything inside the spindle. Okay, so what we do is you're going to need a second person. So you're going to need a third hand for this. If I was in a situation to use this method, I would have Lance help me. So what Lance would do is I'd probably have him on this side over here, and Lance's job would be just to secure, just to hold on to the spindle at this end right here. Okay, but before you do that, you want to line up the slots so it's horizontal. So like that. Okay, so then Lance is going to be holding on to it like that. Okay, then what you want to do is you want to take your 1/8 inch punch, 2-ounce hammer. Actually, maybe a little bit. Okay. Okay, you got to be really careful, because this is where you can easily damage the slots right here.
Well, didn't you say you're really just trying to do a shock hit?
Yeah.
That's really it.
You don't want to whack on it. That's a good point. You don't want to whack on it. We just want to give that shock, because it's on super tight. And remember, these are small little parts, so it just needs that little shock.
Need a little help to get moving.
Yeah. So while Lance is holding on to this end with the soft jawed pliers, I would just make sure this is on it really good. If it's not on all the way, it will damage that slot. And just like that, just do a few little taps. Not much. Do a few little taps, then turn it 180 degrees to the other slot, and then do a few more taps on this side. And I guarantee you, I've never, doing this method, and just take your time, I've always been able to remove the nut with very minimal damage on the slot. So very important, very good technique, we feel. But we got lucky on this one. So let me take this off. There we go. And again, a lot of dry grease. See, and how this works, just see if I can get a better view. Okay, as you see, there's that little fastener that locks the nut. And see how it works is, so they cut a little slot. So when you tighten this screw, it's bringing the two pieces together and then causing it to lock onto the threads. And that's how it works. So like when you tighten it, don't, again, be very gentle. It doesn't need to be tightened. Don't torque it to death, just very lightly, and you'll be fine. Okay, and I think that's done. Yeah, I think that Oh, one last thing. Okay, at this stage, before we go to the hydraulic press, now's the time to remove, especially on this accessory spindle, we want to remove it. So in case of the grinding attachment, we want to remove it from the bracket. If it's the milling attachment, you remove it from the, the main body. And in this case, it's just 2 socket head cap screws. Oh, the other thing, on all Levin parts and machines, everything's imperial, no metric fasteners. Okay, in this case, I believe it's 1/8. Okay. Okay, there we go. So now this is ready to, we're ready to take this to the press. Okay, now if we were doing the open style headstock, okay, so let's say we got the nut off. Now the next stage for this guy is now we want to remove the set screw from the belt pulley completely out. We want to make sure it's completely out because the tip of the set screw does go inside the spindle slightly. So we want just to be safe, we just want to completely remove it so it doesn't damage the spindle. On the closed style headstock, we actually want to remove this locking mechanism completely. And how that's removed is you'll see 3 little socket head cap screws, and that's it. So you just loosen those 3 screws and this whole mechanism just pops right out. And then that's it. So we do that to, depending on the spindle you're working on, that's all you need to do, and then we're ready to go to the hydraulic press. So, is that good?
That's really good.
All right.
Part 2, Section 4, Pressing the Spindle Out.
Okay, we're at the hydraulic press right here, and we're gonna remove the spindle part from the spindle housing. Okay, and let's see if I can come up. Okay, our goal is, this is what we want to do. Okay, especially on this accessory spindle. Okay, what we're going to do is we're going to take this to the press this way, and we're going to use the press to push this spindle down. Okay, while doing that, the spindle wall, or the housing wall, is very thin. So what we're going to do is we're going to secure this on the platform where we don't want to touch the spindle part, but we're going to go actually on the housing wall and over the bearing. So we know that when we push down, the bearing is going to come down and it's going to stop once it hits the platform. Okay, that's fine. And mainly what we want to accomplish first is we're just going to press this until the bearing at this end passes the threads. That way we should be able to just pull the spindle out. Okay, at that stage, the bearing on this side will be completely off the spindle, but the bearing on the other side is still going to be attached to the spindle. And then for the other headstocks, we don't have the problem with the housing, where, see, we can put this on the platform much easier. But again, we're going to do the same type of method. Yeah, the method and procedure is going to be identical. So I think we're going to move over to the press. Okay, only for this accessory spindle, because it's so small, I want a really nice even platform. So I actually use this bearing separator for this purpose. For the headstocks, I don't use this. I just put the headstocks directly.
Is that the one we showed from the workshop?
Yes.
Okay.
So we've talked about this part being required already.
Great.
Okay. So for the headstocks, I just lay them right on this platform. But for the accessory spindle, I use the bearing separator. Okay, what I do is I open it just enough. That way it doesn't touch the spindle head right here. Okay, so let me kind of center it. Okay, and we might want to make sure it's not touching the spindle head. Okay, just like that. That's perfect. Okay, as you notice, I have a little block of Delrin. Okay, very important. You know, again, we don't want to damage any parts. So, actually, I forgot to put this part on. Okay. Okay, so yeah, we want the piece of Delrin in between the two pieces so we don't damage anything. Just like that. Make sure the spindle head's free. Again, take your time. Okay, that looks good. Okay, remember, when you're using the hydraulic press, remember, we want to go slow and easy. Don't go fast. You know, we want to just, you know, study it. You know, we don't want to, if it takes excessive force, we want to stop and analyze it because it really shouldn't be in there that tight. So we just want to go really smooth and easy. Make sure that looks good. Yeah, I'm just putting my hand on the bottom because in case, no, actually it shouldn't fall out, but I just like to keep my hand on the bottom just in case the spindle falls out. I don't want to have it hit on the top of this table and damage it. Yeah, I can feel it. Okay, but it feels good. Oh, there we go. Okay, so just like I mentioned, so the bearing did slide a little bit, like I told you, and then the other bearing is completely off. So let's just set this aside right here. Okay, let's see if this. Okay, we're gonna need another tool, so we're gonna come back to this one. Okay. Okay, this is the spacer. This one should come off with your hand. Okay. Okay, now that we got the bearing partly off, we have to readjust the bearing separator because we want to go as close as we can just for better rigidity. Okay, so just like that. Okay, again, we want to make sure the spindle is not touching the separator. I think that's good. Put a little block. Remember, I got my other hand underneath because the spindle part is definitely going to fall now. Okay, still feels good. I'm not feeling any resistance. And there it goes. So we got it off. Spin this up. Okay, so we got one bearing off, or actually both bearings off. So this is done. We got the spacer off. So let me put these aside and then come back. Okay, now back to this guy. Okay, you'll notice I talked about this prior. Okay, we've got the external spacer still in the housing. Okay, that's a press fit. Okay, and we're going to leave that in there. There's absolutely no reason to remove it. The only time we remove it is if there's a lot of rust, and there's rust, between the two parts. then we have no choice. We've got to press it out, de-rust it, and clean it, and then press the part back in. But as you can tell, yeah, it's really dirty, a lot of dried grease, a lot of oil, but I don't see no rust at all. But Lance is probably going to be the person that's going to clean this and analyze for wear and damage. So he'll make that determination. You know, if he doesn't see any rust or anything, then we're going to just leave that spacer in there. Okay, so now we've got this bearing stuck in there. So how do we remove it? Okay, I'm going to be back in just a second, and I'll show you how.
Okay, we are back.
Okay, this is the tool I use for this situation where we've got a bearing stuck in a housing. I use a blind hole puller set. Okay, and these are really easy to use. We just need to find the size of the internal race. So let's see. No. Let's see, went the wrong way. See, I think it's this one. There. Okay, let's see if we can. No, that's really in there. Okay, so we get this guy. Okay. Okay, and this really easy. Are you ready, Lance?
I'm ready.
Okay. Again, this shouldn't, let me tighten up a little bit better. Again, this should be, just take it really easy. And there you go. See, now we got the bearing out. Yeah, this tool really comes in handy. Why is it that we always seem to need an endless supply of tools for anything, huh?
No, it's because we like tools.
Yeah, that's a good thing. So, okay, so we loosen this. Pull it, and there. We got a bearing out. So that completes this section. Okay, so where we're going to go next is we're going to go back into the workshop and we're going to lay out the parts and we'll go from there.
Okay.
Okay.
Part 2, Section 5, Preliminary Parts Review.
Good. Yeah, as you notice, we're back into the workshop.
We are.
And we're ready to review the parts. Okay, we haven't cleaned these yet because we want to show them as is disassembled.
This is how I get them after disassembly. This is how this looks to me.
That's right. I don't. If I disassemble something and hand it over to Lance, I try not to touch it because I want Lance to see the parts in their original condition with the grease, oil, and all that.
I gotta see what I see. I'm looking for certain things.
Okay.
And can I say it now?
Sure.
One happy and great thing is there is no moisture here.
Yes.
Aye, okay. Because you don't know what you're getting on this. We don't know. So.
Yeah, we don't know. It's a mystery until we open it up and disassemble it. So
we had some great discoveries.
Yeah, let me switch the camera view for a better close-up. Okay, what you're seeing here are all the parts you saw us disassemble. And really important, I haven't touched them, I haven't cleaned them, because it's really important that when I hand these parts off to Lance for cleaning, that he sees them in the original condition. You know, I want him to see the placement of the grease, oil, and any conditional problems.
Yeah, I'm looking for maybe grease buildup in a whole area or some kind of outer something wrong. So I'm looking beyond just seeing. It's almost like a witness marks.
That's right, and we'll discuss that more in one of the feature sections coming up. Okay, so and what we're seeing right here, just from our initial observation, this is actually good news. This is what we typically see from an old spindle that's never been taken apart. And, you know, this is really typical, the dried grease. And that's really just due to age. You know, grease just dries up, you know, as it ages. And the best news is we don't see any rust or corrosion problems.
No moisture.
Yeah, no moisture problems. So that's really good, because that tells us that this was stored in a good environment. You know, because one of the things we notice initially right away is when we remove the spindle housing from the bracket, if there's any rust issues, it's very common to see the rust between here where the housing sits, and then on the housing itself. So, where it makes that contact, rust will form right here. And see, we don't see any of that. What you see right here, that's just dry grease and oil. So really good. Even the internal race spacer, what you see right here, that's not rust, that's just dried grease or oil. So very good. We don't see no rust problems.
Yeah, when you first start doing this, you do think that's rust though.
Yeah, sometimes it does.
It's the exact same color brown, and you go, oh man, it's. And then you start cleaning and realize there's nothing there. There's not even a stain.
Right, it surprised us sometimes. We think, oh my God, we got rust problems.
So don't panic.
Yeah, don't panic.
You start cleaning it.
Yeah. Okay, and as we suspected, these bearings are indeed new departure bearings. Okay, and that's also good news because these bearings go back a long way. New departure haven't made these bearings for ages, and this is what Levin used to use many years ago. So if you open up your spindle and see new departure bearings, that's a pretty good indication that the spindle hasn't been rebuilt before.
So you're probably the first one in there since the factory.
Since the factory, good point, right. Okay. So that's on the bearings. Then as we mentioned to you, we left the external race spacer in there. Again, unless we suspect any rust problems, we want to leave it in there. No reason to remove it. Okay. The spindle part itself is in really good condition. As you can see, no corrosion issues.
That is literally the first part I grabbed from Patrick.
Yeah.
Because that's where the hard job is for me.
Yeah.
It's really critical.
Yeah, you could see the head's very nice. Even the taper's beautiful.
Yeah,
it really tells us that this accessory wasn't used very much, if at all. It just looks like it was in storage for a long time. And because even the key's in good condition.
Oh.
So, and then, we talked about the spindle nut a bit. And again, very good condition. We just have the dried grease. Oh, and lastly, see, we have no rust or corrosion issues on the threads, on the screws. So yeah, so it's really
right, which would have led down these threads through this.
Yeah, they go through here, and then you would see the rust in these.
Yeah,
threads.
and it starts here. It starts working way down those two threads.
That's right.
Down to that. That's what it does, and then it gets down to this spacer.
That's right. Works its way in and spreads. Yeah. Right.
So that's fantastic news.
Yeah, very good news. So okay, so we just wanted to share that. So so I think that's about it. Oh.
That's great.
Okay.
Part 2, Section 6, Removing the Felt Rings.
Okay, yeah, we're ready to remove the felt rings from the bearing caps. Okay, and just as a reminder, remember, the accessory spindle that we just disassembled has felt rings. The open style headstock has felt rings, but the closed style headstocks don't have the felt rings. So if you're doing a closed style headstock, you don't have to worry about this step. Okay, so I think we're ready. Let's go ahead and switch close-up view. Okay, so what I have in front of me is, I have the two bearing caps. This is the one for the rear of this spindle right here, and this is the one for the front, that goes right over the head. Okay, I think what we'll do is we'll start off with the rear one first. If you remember, we showed you two tools. We showed you a homemade tool that was given to us by one of our mentors, and this is a really neat tool. I'll actually demonstrate the use of this for the next bearing cap, because actually this is the smallest, what do we call it? The lip? Yeah, this is the smallest lip diameter, and unfortunately it doesn't fit in this hole. But that's fine because, we recommended this tool, and I'm gonna show us removing this retaining clip. Okay, just as a recap, so we got the felt ring in the felt ring in here, and then we got the retaining washer right here. That's a press fit. So we're gonna use this to remove that retainer washer, and then we can grab the felt ring. This is where you want to really pay attention, because remember, Levin's discontinued the felt ring, so you can't buy replacements. So you got to be really careful and not to damage your existing felt rings. So what we want to do is, we're going to stick this in the groove, and then we're going to push down. Okay, so that means So we got the retaining washer and then the felt. And see, what we want is we want to stick this part between the bottom felt and the retaining washer. Because when we push down, we want to push down on the retaining washer and not on the felt. So let's see if I can show this. So what I'm going to do is just very gently, I'm going to work this, you know, between the felt and retaining washer or retaining ring. See, this just like that. Okay. And make sure it's like that. See, and just like this, I'm going to push down now. And there we go.
Oh, the felt ring looks good.
Yeah.
Nice. Boy, that's a nice.
Good condition. All we have is, you can see there's dry grease right there. So that's why we have to clean these really well, because, you know, there's going to be dry grease and oil. And if this was used a lot, you're going to see a lot of grime and dust and grit.
We'll be teaching you that, though. Don't go clean that yet.
Yeah.
Okay.
Okay, so let's put this aside. So that wasn't too bad. So this tool works really well. And we could use this tool no problem on a larger one as well. But we're just going to share, you know, another type of tool that even you can make.
Well, I like this tool because it covers a lot more surface area on that delicate little ring and kind of gets in there a little bit deeper than that claw tool.
I'm glad you mentioned that. I almost forgot to mention that, because you're right. Some of these rings, they can really be in there tight, so tight that when you push, when you push down, you can slightly bend this. Because if you notice, this is just made out of aluminum and it's really thin. This is like a washer. But it's not a problem if you bend it a little bit. Just put it on, you know, like a flat surface, like a flat anvil or something, and then just with a hammer, just lightly tap around it to flatten it. But very careful, you know. We just want to get it back into shape again. But that's not too critical. Okay, so for this one, okay, we're gonna do the same thing. So we're gonna insert this through the hole. And again, we want it between the retaining clip and the felt ring, just like this. Okay, but obviously we can't put this on the table and push down. So what I'm gonna do is I'm gonna install it on the spindle housing.
Oh, pretty nifty.
See? So very carefully, I'm sorry, I know you can't see it, but there. And there we go. And see, again, it's in really good shape.
Oh, the felt ring looks really nice.
Yeah, the felt ring looks in really good condition. Mm-hmm. Yeah, very nice. And there you go. Very easy. And I think that's it.
All right.
Great, just put the parts here. Good. I think I'm done with this, so I think the next stage is I'm gonna give these parts to Lance.
Oh boy.
All right, thank you.
Part 2, Section 7, Final Thoughts. And boy, do we both have a couple of final thoughts on this little procedure.
Yeah, we just wanted to talk about the spindle nut. You know, that's that little nut with the little fastener, you know, that keeps all the bearings and everything, you know, assembled. So it's a really important part. But the reason why we want to bring it up again, we just want to reiterate about it in regards to its tightness. You know, a couple of things. You know, if you're going to disassemble one of these spindles to rebuild it, you're going to find that in some cases, some come off really easily, but some are so difficult to remove. You know,
and we think we know why.
Yeah, and it's not really the user's, you know, it's not his fault.
No,
because
it's this typical standard spindle rebuild, as most people know it, right? I guess that's
right. Because see, when you're as you know, as we've been talking about, all these spindles use angular contact bearings. Okay, and when you purchase these bearings, you order these from the manufacturer with a specified preload. You know, we went through that where you can order them light preload, medium preload, and so forth. So what that means is, based on the preload, the manufacturer, they grind the outside bearing races, and they do it to give you the amount of preload you ordered.
Right.
So what that means is, so once they're together and you tighten the spindle nut, it doesn't matter if the spindle nut's just snug or if it's torqued to death.
Nothing's changing.
Right. That's not going to change the preload on the bearing. So that's why it's so important that you only want to, when you assemble everything and torque your, I hate to say torque because that usually means, hard.
No, big spindle,
When you install the spindle nut, you only want it snug, because remember, like you mentioned, that's why there's that little fastener.
That's it, yeah, on here.
Yeah.
That little fastener we have first of all, this nut slotted. So it gets threaded on, it hits the back of the inner race, right?
That's right.
Okay. And then we tighten it, we get it tied up against it, and then after that's there, you just tighten this little screw, as we've talked about.
Right. Forcing
the threads, you're kind of blocking it on the threads.
Right.
With a lot of tension. Not the world of tension, but enough that it won't start the harmonic vibration of loosening.
Right.
It's not going to happen.
Yeah, so you don't have to worry about, getting it super tight so it doesn't, loosen over time. That fastener is going to ensure that it stays on.
Oh, yeah.
Okay.
So that make it, you'll really appreciate it later.
Yeah. And also, what we think happens is, on your larger machine spindles that use tapered roller bearings, see, in that case, you have to tighten that spindle nut to a specified
foot-pounds
of torque.
The big torque wrench up there.
That's right. Because see, in that case, when using those type of bearings, the amount of torque on the spindle nut determines the preload on the bearings. Because the bearings themselves aren't ground to a specified, the design doesn't allow it.
Right.
It's a completely different design. So that's why,
So they might call for 300 foot-pounds. That's what they want. So
right,
you'll hear it go clunk, and it's a big bar, and the spindle's a lot more. The spindle's this tall, and it's got 10 bearings on it, and it's quite a stack, I call it.
That's right.
Yeah.
Yeah, because we'll share with you, we came across a spindle where for the life of us, we could not get this nut removed.
No.
And we even had to contact Levin, and we just said, what do you do in these cases? And what surprised us is they said, oh, you know what? We occasionally run into the same problem. And like us, they suspect the same thing. A prior user has tried to rebuild the spindle, and they just torqued the spindle nut to death.
Yep.
And really, the only thing you can do is what we showed you. With the light little hammer and using the punch and tapping it really lightly. There's no other way around it.
No, hopefully that's enough.
Yeah, hopefully that's enough. And eventually, that's what we did. Just took our time, and that's how we got it off. But we just wanted to share that because especially when you do the assembly procedure, just keep that in the back of your mind. Don't torque this spindle nut to death.
Yep.
Yeah. Okay. And I think that's it, huh?
That's the end of this part, huh?
Great. Let's go to the next part.
Okay.
Okay.
As watchmakers and micro machinists, Patrick and I thank you for following along with us while we take this journey. We look forward to bringing you another exciting show shortly.